rational expressions is where we left off. Let me change to my other view. I believe it's 1.7 unless I added some pages somewhere. I mean, 1.7. Okay. All right, so today we're going to talk about dividing radical expressions. Now, everybody here knows how to divide, yes? Yeah. Multiply? Yeah. Okay, so this shouldn't be too difficult. So, I've got the nth root of a and the nth root of b are real numbers, and b does not equal 0. Okay? The reason b can't equal 0, where's b sitting? You have a 0 in the denominator of a fraction? No. What does it give you if you do? Undefined. Undefined. Very good. Okay, so I've got the nth root of a divided by the nth root of b. What do you think I'm going to get?
The nth root.
Yeah. The nth root of a over b. So all you do is you divide, look, germs everywhere. All you do is you divide the radicands. Okay? Make sure you cover your mouths when you sneeze. Instead of spraying my entire room. Okay, the nth root of a divided by b. So what you're doing is you're dividing the radicands. Notice what was the same here. The n, which is called the index. Very good.
So if they're not the same index, we can't do it?
Correct. If they're not the same index, you cannot divide. Okay.
I got a question.
Yes, dear.
How do you get that?
The nth root?
Yeah.
Okay, so let me close that out and I will show you.
No, I mean, like, how do you type it?
I'm going to show you. Control, caret, put in your n, go underneath the radical, put in a fraction. Yay. A over b. How'd you take all those notes without knowing how to do that?
I still know how to do that.
Oh, Joey. I know where you live. Are you ready? Yeah. Okay. Let's go to the next page. Can't do it? Okay, dividing and simplifying. Are you ready? Yeah. Okay, divide and simplify. Assume all variables are positive. So we've got the cube root of 32 divided by the cube root of -4. Do we have common indexes?
Yes.
So what do I get when I divide this out? You get cube root of what? -8. Good. Cube root of -8. Now, am I done?
No.
Can I take the cube root of 8? Can I take the cube root of a negative?
No. Yes.
Yes. Why can I take the cube root of a negative? It's odd. The index is odd. Can I take the square root of a negative?
No.
Can I take the fourth root of a negative? Can I take the seventh root of a negative?
Yes.
Okay, so odd indexes you can take from a negative, even you cannot. All right, so what's the cube root of -8? -2. Beautiful. Okay. Yes, dear.
I don't get how you do the cube root.
Yeah.
Like, I couldn't do it on my homework. I didn't understand it.
Okay, cube root means you're looking for a number you multiply by itself 3 times to get the radicand. So, -2 times -2 times -2 is -8. Right? So the cube root, you just take one of these factors. To do it on the homework, if it's like this, you can pop this right into your calculator.
Okay.
And it should come up with -2, yes.
So why can't you, like, do an odd number?
Because is there any, you mean an even number?
I guess so, yeah.
All right, so if I wanted the square root of -4, right? Is there any 2 numbers I can multiply together?
-2.
But remember, they have to be the same.
So you can't do it.
Can't do it. I can't multiply 2 numbers together and get a -4. Nothing that's going to be the same. Those factors have to be exactly the same.
Why does it be the same?
Why do they have to be the same? Because that's what the root means. It's one of the same factors.
Oh.
Okay? Do you understand that?
Yeah.
Do you understand that? How about you? Okay. Okay, so we're moving here. We've got the cube root of 162x to the 5th and the cube root of 3x squared. Now, when you divide variables, what do you do with their exponents? Subtract. When you multiply variables, what do you do with their exponents? Add. Okay, so when you divide variables, you subtract their exponents. So I want you to go ahead and give this one a shot.
Check mine.
Okay, so let's talk about this real quick. So when I divide this out, I get the cube root of what?
Two.
I get what?
54 x cubed.
Okay, 54x cubed, right? Joey?
Uh-oh, I lost my x cubed.
So I have to break it up. Cube root, cube root, cube root. Right? I'm going off my board here. How am I going to break it up?
X cubed is 27.
27, yeah.
2. And
X cubed.
X
cubed.
cubed. And I'm off my board. Okay? So I've broken it up, right? What's the cube root of 27?
3.
Can you take the cube root of 2?
No.
Can you take the cube root of x cubed?
Yeah.
What's, yeah, x. So the only thing I'm left with is the cube root of 2.
Don't you only have to put like the cube root once? I hit with 27 and a 2 and the x cubed.
You could have done it like this. If you wanted to. That's fine as well. Okay?
Wait, what's that last one?
Okay, let's talk. This one should have been easy, right?
Yeah.
Square root of 243 divided by square root of 27.
9.
Square root of 9. What's the square root of 9? 3. 3. Okay, so here we are here. We get the square root of what? 4x cubed. Good, so now we're dealing with the square root of 4. How are we going to break down x cubed? Dealing with the square root.
X squared and
X and x squared, right? Because we need to be able to take the square root of it. What's the square root of 4?
2.
What's the square root of x squared? Can you take the square root of x?
No.
There's your answer. Okay, so you need to break it apart. Remember, if you're dealing with square roots, you need to break a cube down so that you can get something to take the square root of.
Could we go over the next one in the guessing class?
Yes.
Anything for you, Dan?
Need a minute to get this in?
Why is it
For the
turning
x.
us like we're
It's 12. You're very, very close. Very close.
It's good. Can you like, can you recheck it? We're still perfect.
Oh yeah, we are still recording. Okay, so let's take a look at this one. Oops, that's supposed to be an equals, not a z. Okay? Alright, so we've got the fourth root divided by the fourth root. So we know we're going to have a fourth root, right?
256 x to the 14.
256 x to the 14th, excellent.
And that's 14.
Thank you. Alright, so now we need to reduce from here, right? Can I take the fourth root of 256? Yep, it's 4. Good. So that pulls out front. My last piece is trying to decide what to do with this x to the 14th.
What is that?
How did you get that?
Yeah, I don't know how you got that either.
I got
1,024 divided by 4 is
That's all you did.
256. Yeah. And
So-
then the fourth root of 256, put right in your calculator. Is everybody clear how to put it in your calculator?
I broke it down.
So if the
You
root,
don't always have to. Sometimes they come out even.
if you can divide the root into the first number, then you can put it outside.
No, this isn't this divided.
It isn't?
No.
Then where did you get the 4?
Fourth root?
No,
Fourth root of 256.
it's 4.
Yeah,
I thought
here.
it was 2.
We'll show you.
This
It
is
might be.
aggravating.
Yeah, I'm not getting where you're
Well,
going.
relax, and we're going to look at it. So Control I.
Go ahead.
Add a calculator page. Okay, we want the fourth root of 256, right? So, fourth root of 256. When you hit enter, what do you get? 4. 4. My projector's messed up. 4, right? So you see how we got the fourth root of 256 now?
So I could do that with almost everyone now?
Not with almost every, with some. You need to check and see if it works before you actually go ahead and finish.
So if I get a decimal, then I don't have to break it down.
Right, exactly. If you get a decimal, you have to break it down. Okay?
Is there no bullying zone signs in there all year?
No. Okay, so we have the fourth root of 256, x to the 14, which we brought out fourth root of 256, which is 4. We're left with this, right? We need to break down the fourth root of x to the 14. We need to figure out what goes into those radicals. Now remember, we need to break it down so we can take the fourth root of it. So let's think how we might be able to do this. Remember, we want a multiple of 4 to be the exponent in order to break it down. So what's the largest multiple of 4 I can get by breaking up x to the 14? X to the 12 and x squared. We're breaking them apart so we can take the fourth root. Okay? What's the fourth root of x to the 12? X cubed. You divide. You can't do anything with the fourth root of x squared, so that is your solution. Please take practice, guys. Lots and lots of practice. Okay, binomial radical expressions. Like radicals. Who could tell me what they think a like radical might be?
Radicals that have the same.
Radicals that have the same index. What else? And same base isn't the word. Inside. What do you mean by inside?
You have to get it so it's not underlined anymore.
Same index
That is gonna drive me.
and
Aim index.
There's no S.
why is it blacking out?
That's what you got.
Same index and same what? Base. Now I'm thinking about
Oh
Vinny
my
saying base.
Mine's underlining
I know.
and saying Radican.
Radican, yep.
Can I make that stop?
I don't think so.
That's gonna annoy me. Yeah, me too. Like my OCD.
Same index and same radican. Well, it's important, so it's good that it's underlined. Same index and same radican. Very important that you have those things. I don't know why it's playing games with me here.
Oh my god, Olivia, I found it. How do you do it? You highlight it.
Highlight it.
And then go to menu, you go to format, and you hit underline, and it didn't do anything. Oh, hold on.
What is that?
Try
Can you
again.
highlight it?
Caps and your button, like your scroll thing. It worked.
Yeah, we're.
Alright, explain it again.
Hold on, let me type it. You highlight it,
Uh-huh.
and then you go to menu, and then you go to format, and then you hit underline.
You're recording this year.
I know I am.
Well, I just taught people how
How
to
to-
use them.
yeah. I'd be
So
able to
same
find
index
that.
and same radical.
Same index and same radican. Next page. We have 5 cube roots of x minus 3 cube roots of x. We have like radicals.
Yeah.
Yes, so all we have to do is subtract the coefficients. 5 minus 3? 2. So we literally get 2. I don't know why it's staying on there like that. I don't want it to. 2 cube roots of x. Not funny.
Hey!
2 cube roots of x is your answer. Very good.
Let me draw.
I don't know why it's doing that. I have to play around some more with it, I think. Okay, so B. 4 square roots of 2 and 5 square roots of 3. Do we have like radicals?
No.
So can we combine them? No. So leave it alone. Leave it alone. Can't do anything to it because we don't have like radicals. All right, so I want you to do C and D, please. What'd you get for C?
5 squared is 7.
5 squared is 7. Excellent. And D?
9 squared roots of x, y.
Good job. You got them all right.
I like these.
Good, I'm glad. Let's go to the next page.
Yeah.
Okay, no, they don't get that much harder. All right, simplifying before adding and subtracting. Now, do we have any like radicals?
No.
But look at 18, 8, and 72. What do you know about those? They can be reduced, right? All right, so we have to reduce them in order to find the like radicals. So we're going to reduce them. How are we going to break down 18? 9 and 2. How are you going to break down 8? 4 and 2. And how are you going to break down 72? 36 and 2. Now what do they all have in common?
2.
Square root of 2. So are we going to be able to find like radicals? Sure. Yeah. I'll wait for you. I'll get that in. Okay. Square root of 9 is
3.
3 and 6 becomes, thank you, square root of 2. Okay, how about this one? Careful. 8. Because you have to break down the 4, which becomes 2, correct? All right, how about over here? 18, good. 18 squared root of 2, excellent. So we get 18 squared root of 2 plus 8 squared root of 2 minus 18 squared root of 2. And real quick, you can tell me the answer is? 8 squared root of 2. Very good. Because you have 18 squared root of 2 minus 18 squared root of 2.
Wait, what?
Hold on, I need to break this down.
18 squared root of 2 minus 18 squared root of 2?
No, how'd you get 18?
Oh, square root of 9? 6 times 3?
Oh, you multiply.
Correct. Once you have this one done, I want you to give B a shot, please. You're going to have to reduce them. Are we ready? Yes?
Yes.
Say yes, Mrs. Cucci, I'm ready.
Yes, Cucci, I'm ready.
Okay. So, how are we going to break down 50?
25 and 2.
25 and 2. Good. How are we going to break down 32?
4. Yeah.
16 and 2. How are we going to break down 18?
3.
9 and 2. Okay, were we able to break them down correctly?
Yeah.
All right, next step is to take our square roots. Square root of 25?
5.
So we get 5 square root of 2. Square root of 16?
4.
And what do I do with 4 and 3?
Multiply.
12 square root of 2. And how about here?
3.
So it becomes
15
15 square root of 2. Excellent. So now we have 5 plus 12.
17.
So you get 17 square root of 2 minus 15 square root of 2.
2 square root of 2.
How many people got this right? Raise your hand. I'm so proud of you. Okay, good job, guys. Need it up for a minute?
Yeah.
Okay. Okay, multiplying binomial radicals. How do we multiply binomials together? FOIL. Good. Who remembers FOIL? All right. FOIL. What does the F stand for? First O. I. L. You guys are so smart.
We know.
Okay, so we have to FOIL. Now, first terms. First, this becomes 6. Outer.
Can we actually write out the FOIL?
If you'd like to, yes.
Can you move the cursor, please?
No, I don't know how. 6 plus 12 square root of 5. Inner. We'd better be putting this down, Mr. Cooper. 4 square root of 5. And last terms? 8 square root of 25. Perfect. Okay, 6 plus 12 square root of 5 plus 4 square root of 5 plus 8 square root of 25.
Square root of 25 is 5.
Correct.
Why did you add 6 plus 12?
You could. Not. You cannot do that. They're not like radicals. Are they? But we can.
Add those two?
Yes, we can. And what can we do over here? Yeah, what's the square root of 25?
5.
So this becomes 8 times 5, right? 8 times 5? 40. So we've got 6 and 40, which becomes
46.
And we've got 12 and 4, which becomes 16. This is your answer.
Where did that 46?
Where did I get 46 from?
Oh, how can you and make it?
Are they like radicals? So you can't combine them. Okay? Need a minute?
Yeah.
What does it mean to square something?
Multiply by itself.
Multiply it by itself. So tell me, how would I do that?
Square times y.
It's just gonna be 2 minus 3.
No.
Oh, that's
Oh,
it.
that's
half
square root of 2 minus square root of square root of 4.
You have to multiply it by itself. You cannot just square what's in the parentheses. Squared means you're literally multiplying it by itself. If you just square everything that's in it, you're not doing that.
When
Okay?
you square root, isn't it? So,
Yes, it is.
oh.
All right, so now we can do this, right? First terms. What do we get?
You get like
What's the square root of 2 times the square root of 2?
square root of 4.
What's the square root of 4? So what happened when I multiply it
so
by itself? This is just 2,
Oh.
right? If you multiply a radical by itself, it's just the radicand. Okay? Square root of 2 times negative square root of 3?
Negative square root of 6.
Negative square root of 6, good. Negative square root of 3 times square root of 2?
Negative square root of 6.
Good. Negative square root of 3 times negative square root of 3?
3.
Good. So if you multiply a radical by itself, you get rid of the radical sign. All right, so now we're left with this. We need to combine our like terms. 2 plus 3.
5.
Negative square root of 6 minus square root of 6.
Negative
Negative 2.
2 square root of 6.
Perfect. Nice job. Okay, the conjugate, I need you to somehow make sure that you know this page is very important. So if you're going to write very important, or if you're going to put stars or put something, make sure that you know this is important. Okay? You will be tested and tested and tested and tested on the conjugate. I guarantee at least 2 problems on the Regents exam has something to do with the conjugate. Okay?
You don't underline that.
Conjugate is important. You can underline it because you know how, Megan. Very good. All right, so, yes.
Is there?
Probably
What's the multiplication sign?
in the
Minus sign makes
little multiplication sign, or you could go here, and it's probably in here somewhere as well. Right here.
Yeah.
You're welcome.
If you put it right next to the conjugate, it kind of, yeah, right? It's already folded.
That's true. I got bit. What? I don't know. I don't know. Okay, so 3 plus the square root of 2. Please put that in. 3 plus the square root of 2. Do I have? Three plus the square root of 2. If I want the conjugate, boys,
How'd you get the arrow?
the arrow, you're going to go control book, control catalog, and then scroll down and you'll see it. Okay, the conjugate to this is 3 minus the square root of 2. What's the only thing that changed? The sign in the center, right? All right, so 4.
We already did that job.
Okay, so now here's this one. What do you think the conjugate of this is?
Negative 4 minus.
Perfect. Negative 4 minus the square root of 3. So when you take the conjugate, what's the only thing that you're changing? The sign in the center.
What happens if it's like 4 square root of 3?
Then we'll talk about that in a couple
Where'd
minutes.
you get the arrow?
There's no conjugate to that.
Control bar.
Okay, so this is the conjugate. This is very important.
That's all you're going to switch in the middle piece.
All you're doing is switching the middle piece. Okay? So if you look down here, I've got us multiplying by a conjugate. How am I going to multiply those? FOIL. So I want you to go ahead and multiply that out for me and see what happens. Let's FOIL. 2 times 2? 2 times the negative square root of 3?
Plus 2 square roots of 3. Oh, sorry, minus.
Minus 2 square roots of 3? That's
Plus 2 square.
plus 2 square roots of 3. And here?
Minus square root of 9.
Minus the square root of 9. Perfect.
Oh.
Negative 2 square roots of 3 plus 2 square roots of 3. What happens?
0.
They go away. And left with 4 minus square root of 9?
3.
That's 4 minus 3. What happened to our center terms, outer and inner, when we FOIL?
They cancel each other out.
They cancel each other out. This will happen every single time you multiply a number by its, or a binomial by its conjugate. Okay? So every time you multiply a binomial by its conjugate, the center terms will always cancel out.
So, could you just do F with L?
Exactly. You don't have to do the whole FOIL when you're dealing with a conjugate. Just do the first terms and the last terms.
Oh.
That's going to save you some time. Okay? All right. So go to the next page. Let's look at how this works. Okay, so one of our rules for math is you can never leave a radical in the denominator. You can't do it. Okay? You have to what we call rationalize it. And in order to rationalize it, you have to multiply by the conjugate. Okay? So what's the conjugate here?
3 minus
No, denominator.
1 plus.
So you're multiplying the numerator and the denominator by 1 plus the square root of 5. What's 1 plus the square root of 5 over 1 plus the square root of 5 equal? 1. So am I changing this? Am I making it different? When you multiply something by 1, does it change it?
No.
No, it's just going to make it look different. That's all. Okay? So now, all you would have to do is FOIL the numerator. Remember, you have to FOIL the numerator completely because you're not dealing with the conjugate of the numerator. The denominator, you only have to multiply the first terms and the last terms. Okay? We're running short on time. I'm not going to finish this as of right now. I just want to show you one other thing. Okay? If I gave you something, you don't have to write this down. If I gave you this, something like this, square root of 3 over the square root of 2, can I leave it like that? No, because I have a radical in the denominator. But is there a conjugate?
No.
So all I'm going to do is I'm going to multiply the numerator and the denominator by the denominator, which would give me the square root of 6 over 2.
So what have to be the negative square root of 2?
Nope, not for the single ones, not for binomials. You're just doing the denominator itself. Okay? So, we're going to do more practice with these next time. We're running short of time. Homework for tonight, do more of your weekly project. I think there's only one problem on there you may not be able to do. Homework for tonight, I want you to pick a couple more division and multiplication problems and do those. All right?
Should we do division problems now since we had 10 multiplications?
Yeah, I'm sorry, that's right. I forgot your class didn't do the division. I want you to pick 10 division, and when you get a radical in the denominator, I want you to try and rationalize it, which means you're going to have to multiply by the
How would you
conjugate.
multiply that?
In the numerator, you have to FOIL. So you get 3 plus 3 square roots of 5 plus 1 square root of 5 plus 5 over 1 minus 5. Right? 1 times 1 square root of negative 5 times square root of 5 is negative square root of 25, which is negative 5. Okay. So we would get 8 plus 4 radical 5 over 4. Negative 4. Okay. Then the last thing you could do is actually divide. And then this will be your solution. Okay. And we'll finish this